Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic, that is a virtual memory, and we will also start the discussion about pure demand paging and we will start the discussion guys. Okay, yes, okay. So when it comes to virtual memory, every student will be thinking like virtual memory is a type of memory in which you can store something infinitely or something, the students will be thinking. But there is no concept of virtual memory guys. So it is just an illusion type of thing you can say. So basically virtual memory is nothing but so let us understand in this way guys. In this way it will be easy. So assume that your RAM is 8 GB guys. Okay, so at max how much size file can you open in your system guys? So with the basic understanding you will say that so at any moment of time only 8 GB can be stored in my memory. So at that time only a movie of 8 GB above cannot open, you will be thinking in that way, right? Yes, but by understanding the concepts of paging and all those things, most of the students might have already understood that. So if that movie has been broken into multiple pieces, so only at any moment of time only few of those pieces will be in the main memory and the rest all pieces can stay here and some other program can take some other place, right? Yes, so in that way, using a minimum space, we are going to utilize it for the maximum, right? And in nowadays the scenario, we want that only, right? So we want to run hundreds or sorry, not hundreds, tens or twenties of programs in the background. So you will download a movie, you will watch a movie, you will download some other thing, okay, you will run something in the background. So there are various things, right? Yes, so that is the reason why always we are behind this memory, right? Yes, so as it is only 8 GB, most of the people will be thinking like anything with if it is over 8 GB we cannot open, but that is not the case. So whenever you ask someone, they will be saying it will be stored in the virtual memory, but they also don't know that what is virtual memory. So virtual memory is nothing but, so this secondary memory is there, right? So assume it has a 2 TB. So basically this 2 TB will act like our main memory guys. So indirectly the programs or whatever we are running will store here only, but only the thing which are running will be brought here. So indirectly you can run as many files as you want, right? So that is the exact concept here guys. So the only goal here is by using the virtual memory or any kind of memory, our goal is to run various programs and to maintain parallelism, right? Like simultaneously they are working, it should look in that way. So that's what is our goal, right? Yes. So one important goal in nowadays computing environment is to keep many processes in main memory simultaneously, to follow multi-programming and use resources efficiently, especially main memory, right? Yes. So now you understood the thing, okay? Yes. So that's the concept of main memory guys, sorry, virtual memory, okay? Yes. So now you understood it, right? Yes. So now what is a pure demand paging? So pure demand paging is the concept with respect to virtual memory, you can say. So basically what does this paging approach says is, so if you are bringing a particular packet or a particular segment or a particular page from secondary memory to main memory, bring it only if it is needed. So basically don't bring unwanted things. So that is what this pure demand paging says guys. So everything is almost the same here also, okay? So you can observe from the diagram also, right? Yes. So this is our secondary memory. We will bring some blocks as per our requirement into the main memory, and those items are shown in our page table. So here we are using V and I guys. So V means valid and I means invalid bits, okay? So just to say that whether there is any kind of a frame value inside or not. So just to identify that we are using that, okay? Yes. So now you got some basic idea with respect to this demand paging, right? Yes. Okay. So now most of the students are like, okay, so we understood the whole concept of paging, but now once you discussed this demand paging, we got a doubt here. So the doubt is, so what if the main memory is full? So assume that I told previously we discussed with 8 slots, right? Yes. So assume that all of those 8 slots are full. Then what you will do? So then if a new slot, the 9th slot comes and says that he or she wants a space, so what you will do? So we need to kick someone out from this particular 8 members, right? So means who to kick? Whom you will select? So that's a question, right? Yes. So those are nothing but the page replacement algorithms, guys. Got it? Yes. So in computer organization, we have already discussed this same topic with the name cache replacement algorithm. So there we are replacing the cache items, right? Yes, but here we are replacing the pages. That's the only change here, guys. So the rest whole, the concept, the approach, everything will be the same, okay? Yes. So anyway, I'll be discussing about those all 3 algorithms and everything in the next lecture, so don't worry. So first of all, let us understand What is a page fault? So basically page hit means what, guys? So if you found the page directly, it will be a hit. So fault means it is a miss, right? Yes. So when a processor tries to access a page that is not in main memory, so it is not available currently in the main memory, then it is a fault. Okay, so observe here carefully, guys. So this flowchart will explain you everything here. Okay, so assume that this is our operating system. Okay, and this is our secondary memory, this is our page table, and this is our memory. Assume in that way. So assume that, so there is a function like load m. Okay, so what it will do, it will go to that memory location, right? Yes. So it is going to give some page number and all those same concepts. So basically this is again divided into two parts, the function. So it will have a page number and it will have some offset. So once you found the page number, what you will do, you will go to the page table and you will check whether that page is available in it or not. So assume that it is empty. So basically that slot is completely empty and there is a letter I at the end. So what does I means, guys? So I means it is invalid, right? Yes. So you understood that there is no packet or no page of that particular item which we are searching. So what you will do, you will inform operating system that we want that page, please bring it. You will request operating system. So operating system will take that trap. So it will raise a trap so that it will be received to the operating system. Operating system will, what it will do, it will be selecting the particular segment, so which you are selecting. So assume that you are selecting P segment or P page. So that page will be identified in the secondary memory and that page will be brought to the page table. So basically that page will be brought to the main memory and that main memory location will be updated in our page table. Okay, so if our main memory is completely full, so someone will be kicked out and he will be pushed into the secondary memory, right? Yes. So now that particular thing will update this, and if someone asks again, so basically after some time this guy will again ask, right? Because his request didn't didn't fulfill. So that is the reason why he will ask again. So now if he asks, it will be valid right now. Yes. So now the page will be found. So this is the concept of a page fault, and in that way the progress will work, guys. So now everything is 100% clear here, but whom you will kick is the question here, right? So there you are going to get the page replacement algorithms, guys. Okay. Yes. So now you understood, right? So in the next lecture, I'll be discussing in detail about a page replacement algorithms, and we'll be discussing all three types of page replacement algorithms in the next lecture only. Okay. Yes. So I hope everyone got at least some basic idea with respect to this virtual memory and pure paging or demand paging, right? Yes. And page fault. Okay. Yes. So in the next lecture, let us discuss about a page replacement algorithms in detail. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.